after a gap because of some reason, personal reason, there was a gap, of course. Let us continue the heteroscedasticity. In an important assumptions of the classical linear regression model is that the error term, they have the same variance for the population regression function, in the sense they are homoscedastic. But in heteroscedasticity, it is not the same. Means there may be a change in the variance of disturbance terms. As I said earlier, in the disturbance term, not a single factor may not be there, more than one factors. But all the factors have different variance. But in homoscedasticity, the variance is the same for all the factors. But in heteroscedasticity, it is not the same. That is, expected value of this ui squared, that is the error term or the regression term, disturbance term, is not uniform. That is, expected value of ui squared is sigma I squared. Means expected value of sigma u1 means first error term is sigma 1 square, and expected value of the error term u2 squared is sigma 2 squared, etc. etc. So I can give an example for that. See, suppose in a linear regression model, say x denote y equal to beta 1 plus beta 2 xi plus ui. Here x denotes the income and y denotes the expenditure, say, on the food. It is observed that income may increase. So as the income increases, the variation in the expenditure on food increases, because the choice of consumption, choice of food item or variety of food item is not the same in each family. So in each family there is a change. There is a change, or the choice is different. So varieties also change in food. Varieties so increase in a general up to certain extent. But the variance of the observation on y will not remain the constant as income changes. So this assumption of homoscedasticity implies that the assumption of the pattern of food will remain the same irrespective of income of the person. This may not be generally be a correct assumption in the real situation. Rather, the consumption pattern changes, and hence the variance of y, and hence the variance of the disturbance will not be the same or constant. I can give one more example. Suppose that in a simple linear regression, the x denotes the number of hours of practice for typing, and y denotes the number of typing errors per page. See, x denotes the number of hours of practice for typing, and y denotes the number of, they say, typing errors per page. So in the homoscedasticity, what was the assumption? Assumption was, as the practice increases, typing per page is the variance of typing page is the constant. That was actually the assumption. It is expected that the number of typing mistakes per page decreases as the person practices more. This is actually practice. In practice it is so. So homoscedastic disturbance assumptions implies that the number of errors per page will remain the same irrespective of the number of hours of typing practices. But it is not true in the practice. This is the concept of heteroscedasticity. So its meaning is here, heteroscedasticity is a systematic pattern in the errors where the variances of the errors are not constant. Heteroscedasticity occurs when the variance of error terms differ across observations. In the sense, as in the case of typing, the number of hours increases of practicing, the error will decrease, typing error will decrease. But so the variance is not uniform. But in the classical linear regression model, we have assumed that the variance is constant. But here it is not constant. That is true also in the practice, real life. So meaning is here heteroscedasticity implies that variances that the dispersion around the expected mean of the residuals are not constant. So these are all the some questions may occur in the MCQ. Example, suppose 100 students enroll the typing class, some of which having the typing experience and some of which do not. After the first class, there would be a great deal of dispersion. Dispersion means more variance, more dispersion, deal of variation in the number of typing mistakes. First, after the final class, the dispersion would be smaller. In the sense, as the case in the case of typing, the typing error decreases as and when the experience or practice increases. This is the homoscedastic pattern of errors. See, the on a black line is there, dark line. So around this line, the points are plotted. These points are almost close in the sense they are uniformly distributed around this dark line. So almost homoscedastic, but in the heteroscedastic pattern of errors, see the dotted points. The points are scattered, so in a haphazard manner. There is no uniformity. Some here above this dark line, some increasing trend is there. Below the dark line, there is increasing trend of dots are there, but the all scattered not in the same way, but they are scattered, not uniformly distributed. So this is the example of heteroscedastic pattern of errors. Now heteroscedastic case, see the here. As the peak increases, variance increases. See here x1, x2, x3, income. So income increases, the consumption, the variation also increases. See the x-axis variation is increased here. The identical distribution for the observations I and j, same distribution. The above is the homoscedastic distribution, and below is the heteroscedastic distribution. See, as the day, and see, this is wider, flat has a wider, in the sense as the time increases, this error decreases, variance also decreases. So this is the all about this heteroscedastic, and example not be I can solve, of course. I will send MCQ questions on that. Then is auto correlation. Let us see in the next class. Okay, thank you.